Okay, guys, so new lesson, lesson three. We're still in the periodic table, and so far you've learned about atoms and different elements, and the fact that there are different groups and different periods, and that properties are similar based on the group that they are in. So today we're going to be talking about one big category of the periodic table. It actually makes up most of the elements that we have, and those are metals, and those are broken up into different subcategories that we'll talk about. Okay, so some properties of metals. Number one is that they're shiny. We're used to seeing that they're shiny, they're hard, they're malleable, they're ductile. We'll talk about what that means in a second. And they're great conductors of heat and electricity, which is why if a metal gets hot, it doesn't take very long for the other end of the metal to get just as hot. The reason why has to do a lot more with understanding electricity and physics, but I'm going to give you a short visual that may help you. So, typically, if we were to have an atom, let's say this is the nucleus of two different atoms and there's protons and neutrons in here. I'm not doing a specific atom, so if there's not the right number of protons and neutrons, that's not the point right now. And typically, you'll have a couple electrons around each atom. If this were like a nonmetal and a metal or two nonmetals, typically what you would have is like one electron would go over here, or they would share electrons, something like that. But with two metals, it's a little different. What actually happens is it creates this basically this C, like SEA, and all the electrons can go anywhere within this area around either atom. So then what happens when you have a bunch of these metal atoms in here is that these electrons can bounce from one atom to another atom way over here, to the atom right next to it, to an atom all the way across the metal bar, where typically those electrons would have to go one by one by one, which makes conduction a lot longer. So basically, the whole idea of why metals are really good at conducting is because those electrons can kind of travel back and forth throughout the metal very easily because of that whole sea of electrons. Now, most of our metals are also going to be solid at room temperature, pretty sturdy solids, with the exception of mercury, which is a liquid at room temperature. Their shininess is what we call luster. So if you were to look at like an elemental table, they'll have different luster values on there. Malleability is basically how well something can be hammered or shaped into something else. So if it's really malleable, that means you can hammer it into a lot of different sheets and shapes. Another reason that metals are really malleable and they can be manipulated into different shapes without breaking is because of that sea of electrons. Those electrons can kind of shift and move out of the way and go around other atoms if they need to, so it's easy to change the shape. Ductile is similar to malleability, but it specifically means that you can form it into a wire. So now we have one of those categories of metals. If you look at this periodic table here that's labeled for you, it's color coded, and a lot of periodic tables will do that. The whole blue section are all metals. So you notice that most of the periodic table is metals. But this first group, because remember, groups have similar properties, are alkali metals. Now, hydrogen is always on top of there. That's an exception. We'll talk about that in the next lesson. But from hydrogen down, we're going to have our alkali metals. These guys are extremely reactive. The reason they're so reactive is because they have one outer electron. And everybody wants that 8. Remember I said that before? So for many of them, if they lose that one electron, they're going to have 8 from their last shell. So many of them want to hurry up and get rid of that one, so then they'll just have 8 left on that outer shell. So these guys are super reactive, primarily with these guys over here, because these guys have 7, so they're always looking for one more. Get rid of that. They're softer, but they're the most reactive, so it's really rare that you'll find any of these occurring naturally in nature. So they have to store them in special ways so that they don't just react readily with the water or the oxygen in the air. So the alkali earth, pretty cool. Main thing to remember is their name, where they're located, group 1, and that they're extremely reactive. Group 2 metals are pretty similar to group 1. These are the alkaline earth metals. Don't confuse the names. You have your alkali and your alkaline earth, but similar idea. These guys only have two, so slightly less reactive, but same idea. They want to hurry up and get rid of those two. So still very reactive. And just like the alkali, it's really hard to find these just by themselves in nature. Still shiny, still malleable, still ductile, pretty much the same thing as your alkali. Oh, also, cool thing, some of these react in ways that give off different colors. So a lot of times things like magnesium you'll see in fireworks. So your transition metals, these are the guys that are in the middle, that like shorter part of the periodic table. It's also longer, the part that we skip over when we counted the electrons last week. So our transition elements are the ones we typically think of when we think metals, right? Like our silvers, our golds, our coppers, our nickels, our irons, all those guys are our transition metals. These are our very hard metals. These guys are from group 3 to group 12. Um, but the ones that we typically go to when we're talking about the periodic table and the ones that are referred to as our representative elements are the ones outside of those. So groups 1 and 2, and then groups 13 through 18. Those are the ones we count across to figure out the number of valence electrons. The reason we couldn't count across with the transition metals is because they vary. Sometimes a specific metal will have 3 outer electrons, sometimes it'll have 2. So it kind of depends on like what it's reacting with. And then the last category of metals we'll talk about are these inner transition metals, also known as our lanthanides and actinides. Lanthanides is the top row, actinides is the bottom row. This is what a periodic table would look like if you were to actually stick those inner transition metals in there and make the whole periodic table across. But sometimes it's harder to read that way, harder to fit on a piece of paper well, so they separate it and put it at the bottom. That's how you're typically used to seeing the periodic table. These guys have a lot of radioactive ones. They're used for things like nuclear weapons, creating lasers, creating computer parts. They're really interesting. Some of them are used for medical purposes. I like the inner transition elements. If you ever want to research some elements, those are some really interesting ones. But similar properties as the other metals. Ductile, shiny, malleable, solids, pretty much the same idea, just knowing where they are and where they're located. So that's pretty much all of lesson 3. Main things I need you to know are what are the general properties of a metal, what are the different categories of metals, and then can you describe the properties of each of those categories?